Good morning and welcome to my keynote presentation this morning for the ICENIS2020 conference at Schijndel University in Indonesia. I'm sorry that I'm not in Indonesia at the moment because of the COVID situation. My name is Patrick van Schijndel, as I was introduced. I'm attached to the University in the Netherlands, Eindhoven, University of Technology, and my background is chemical engineering, and I'm an energy specialist, sustainability specialist. And special thanks for the organizing committee for this conference, especially also Professor Hadianto, who invited me to give this keynote speech, and the moderator for today, Professor Subrobowati. And also special greetings to the Magister Energy team, Professor Windarto, who have worked together in the last 15 years. My presentation focuses on trends in domestic energy use and domestic renewable energy production, and I will first give an introduction of myself and on the topic, followed by innovations to decrease home energy use, and then thirdly renewable energy production at home, and some conclusions. I give a very broad keynote speech, and for all those who are interested, they can always contact me. So first of all, my introduction. I studied chemical engineering in Eindhoven, and I was attached to this university for quite some time. I'm specialist in international collaboration. I did a project in Tanzania, setting up a master in environmental technology between 1996 and 2003, where I also did a lot of research on cleaner production, XG analysis, energy efficiency, life cycle assessment, and later on also renewable energy. And since 2005 I also have my own consultancy firm. In the 2000 years I did a job for the International Relations Office at TU Eindhoven to run a couple of international programs. And I also worked for United Brains, Kunststoffenhuis, for the Indonesians that know me, a CICENIS program, several niche projects, and last but not least, a project I finished this year for TU Eindhoven, the Bridges project, setting up an electrical engineering program in Somalia and Somaliland. For a little bit of my own my own influence on sustainable development, because you can teach on renewable energy or sustainable development, and I always ask my colleagues, what did you do yourself in your home situation? Do you already have solar panels or not? So first of all, I helped in setting up sustainable and environmental education in several universities around the world, in South Africa, Tanzania, India, Indonesia. I worked on several energy efficiency projects in the industry, internationally, but most also in the Netherlands. Recycling projects, energy efficiency projects, sanitation project we finished a couple of years ago in Bintan Island in Indonesia. In Sweden, where I lived between 2011 and 2018, we had 5.5 kilowatt in solar energy. And we heated the house on wood pellets and own wood production. And now, as you see, this is not Sweden but Portugal. We also have solar panels just installed, and we heat on our own eucalyptus wood. And for the future, maybe electrical driving would be possible. So when I move to slide number 5. I always used to start my presentation with the global overview of primary energy use, and to show that renewable energy is slowly rising over the years. And what you can see, the trends are clear. Global energy is rising steadily. Coal, natural gas are still rising. Oil only slightly, mainly for transportation. And renewables, mainly for electricity, are on the increase steadily. Of course, important is to know how will our population grow, because our population growth determines our economy growth, and that determines our energy needs. And of course, an economy that is more efficient in energy will use less energy per capita, but when we still have more people, we still need more energy. And there is where we need energy efficiency, and there's also where we need renewable energy. So when I go to slide number 7, population is growing, more energy is needed. At this moment, COVID-19, we see a trend. Economy is going down, traveling is going down. I cannot go to Indonesia right now, like many other people. So currently we have a decrease in, even a decrease in energy, but we don't know if it's just short-lived or long-term. Now my keynote speech is about domestic energy use, and when we look at domestic energy globally, worldwide, we know that it's, if we include it with personal travel, it's about 1/3 of our global energy needs. So it's quite important. It's also important because we have an influence on how much energy we use ourselves. And if we use green energy, or we produce our own energy with for instance, solar panels. And the other energy users like industry and global transportation, that's not so easy for us people to change that. What are the trends in domestic energy use? And when I look at the northern hemisphere, so the colder climate countries, we know that 2/3 of our home energy goes into cooling and heating, especially heating in the winter periods. And 1/3 goes to hot water and all kinds of electrical appliances that we have. And the trend is that we have more devices all the time. We're having online meetings, so we're using our laptops, computers more and more. And then we expect a big shift in global domestic energy use by the introduction of electric cars. And this is really going fast. We had the expensive cars from Tesla, and we have a lot of other car manufacturers like the Nissan Leaf that's very popular in Europe. And if everyone starts using electric cars and charge it from home, then of course we need much more electric. Slide number 8 shows my previous home in Sweden, which was an old house but built very well in the 1980s. So it had a good insulation, so you need less heating in winter time. Triple glazing, so triple glass, good insulation of walls. We installed 5.5 kilowatt of solar ourselves, and previous owners installed a biomass pellet heater. So you heat the house on the waste from the wood industry. So this shows a house that has optimized for energy. The next slide, number 9, shows trends in the use of fuels for our electricity production. And what is very interesting to see is that coal is decreasing very rapidly. Natural gas is rising, nuclear about the same, oil is slowing down, like in Indonesia, but renewables are really growing very fast. The amount of investments in renewable energy is much higher now than in fossil energy, especially for electricity production. So when we go to innovations in domestic energy use, I mentioned heating and cooling is important. So our insulation, our building envelope is very important. We have an energy labeling system in Europe where an A house is very efficient, an F or G house is very inefficient. But the label itself does not say so much. It's, I think, better to use a value like kilowatt hours per square meters per year to know if a house is well built. And in the Netherlands, trends are go for passive houses that need almost zero heating in winter time, but the question is how comfortable is such a house. And then in the Netherlands we have a discussion on stopping using natural gas for heating, and what's the alternative for that? Heat pumps, solar heating, etc. That's a big question that is being researched right now. Now if we look further to the equipment that we have in the house, of course over time our devices have become more efficient, but these can do much better, and I have a few examples on slide number 11. So now for some examples. This is home-based research. When you're a researcher, you can take your profession back home. And when we moved to Sweden, one of the first things doing was to check a new house and to check how much energy does it use. You just switch off all your devices and you check your energy meter. So with practically no equipment, you can do a research and see what's our idling energy. And you find out, and that's example 2 that I have, that for instance every house in the northern hemisphere has a heating system and a heating pump. That's a pump to pump your water in your CV system, your heating system. And in many places, in many houses, these pumps are first of all too big, and secondly they're never switched off. So even in summertime this pump is running. It's actually idling, it's doing nothing, but it's still using 50 to 100 watts all the time. So by switching off standby equipment, you can already save a lot. So I always say standby, that's nice, it's convenient, but if you want to save energy, switch off the device and find out if your device is not used. Actually, my first example was a dishwasher. You move into a new house, the dishwasher doesn't work, so you buy a new one. Of course you want to buy an efficient one. So we have a labeling system in Europe, and we bought a label A dishwasher. We think label A dishwasher is most efficient. One of the things you can do to increase efficiency of a dishwasher, but also a washing machine, is to do a hot filling. So you fill it with hot water from a hot water supply. So you don't need electricity to heat the hot water. And when we tried this in the dishwasher, we found out that it didn't work. Why? Because this label A dishwasher doesn't have a temperature sensor. So it just follows a program, and just you switch it off, it heats and it keeps on heating. So if you add hot water, your 35 degree mode will become a 60 degrees mode. And then you think, why should I buy a A+ or A++ label device? And I don't like the name. For me, A is the best, and A+ or A++ is a strange naming. But why should I buy a twice as more expensive dishwasher to have a temperature sensor which costs you less than $10 cents or something? That's very strange. So equipment is efficient, yes, but it could be much more efficient, and it's for us consumers to push the producers to do this. My third example is more about knowing. So if people at home get an energy bill and they need to turn to a professor and say, "Professor, can you read this energy bill of 3 pages?" Then something is wrong. There are so many factors in your energy bill that it's very hard to know what is exactly now the price per kilowatt hour, and no one exactly knows how to do this. Most of the people I interviewed, they don't know how to read an energy bill. They know what they pay, but not how much it costs. The trend is smart meters at home, so on your telephone you can see how much energy you're using, and that's good because you get instant information about your current energy use, and that can help 5 to 10% energy savings. So good information on your energy use and how you can save energy is always very valid, and countries should have this information available for consumers all the time. And I always say, if you get a $10 kilowatt hour meter, you can measure yourself. And that would be a good gift to all households, because I say knowing about your energy use is also saving energy. Okay, that ends my part on basic energy use, and I will continue on renewable energy. Welcome in my solar barn here in Portugal. This is a self-built wooden construction with about 3 kilowatts of sharp solar panels and a German SMA inverter, and for future research also a Victron charger inverter system to use with batteries. So my second part of my keynote is about renewable energy use in the domestic situation and the self-production. Let's start with the use of renewable energy. Because as consumer in Europe you have a free choice to choose your electricity supplier, and you can go for green energy, as we call it. So energy produced from renewable energy sources. Now I must say this gives some discussions on when is electricity green, when is it really sustainable and renewable. And for instance, in Europe we do not consider nuclear power as a renewable or sustainable energy source, but in other parts of the world it's seen as sustainable. I personally disagree on this. And then we have a major discussion in the Netherlands about using biomass to produce green electricity or to heat your homes, while in Sweden, with a lot of forestry and a lot of waste, the use of bio-waste to heat homes, cities and even industrial processes is quite okay and seen as sustainable. To heat the homes right now in Sweden, but also the Netherlands, you can use, if you do not want to use fossil energy, you can use a heat pump. Of course, that uses electricity. Normally these are air-to-air heat pumps, but in, for instance, Sweden, there are a lot of groundwater-to-air heat pumps. So groundwater pumped up from about 100 meters deep, where you have a heat exchanger, where the water is about 25 degrees, is used to heat your homes, and this is more efficient than an air-to-air heat pump. This is quite expensive in the Netherlands to do. Roughly 10,000 euros of investments is needed for such a system. And then of course many cities have central heating systems, so you have a central production of hot water, and sometimes in combination with electricity, and you divide it to the homes. And this is a way to heat your house in a sustainable way using renewable energy and have the investment done by your municipality. But you can of course also use excess heat from power plants or industrial processes. Now I have two sheets, sheet number 14 and 15. 14 shows a pellet heating system, like the one I had in Sweden. Pellets are compressed wood, and in Sweden they're made from the waste from forestry industry. Yeah? If you cut a tree and you make furniture, then you have about 40% waste that you do not use. And when you compress these pellets, you can transport them and you can use them in an automatic central heating system, which operates like a central heating system on natural gas or on electric power. Sheet 15 shows wood. If you have a big garden like I had in Sweden, but also here in Portugal, where we have a lot of eucalyptus trees, you can cut them yourself or have them cut and use them for heating in wintertime. The trees grow themselves, and if you do not cut more than it's growing, then you have a sustainable situation. But of course when you're in a city and you do not have your own garden, then that's maybe a different situation. So we have quite some discussions on bioenergy at the moment in the Netherlands. Now, producing your own energy, like I've mentioned, this barn has 10 solar panels, roughly 3 kilowatts. And we've noticed over time that PV panel systems are becoming cheaper and cheaper because of mass production, mainly in China, but also USA, Japan and Europe. And if you would buy a system now, wholesale in Europe, for a 250 to 350 watt module, I reckon the price would be somewhere between 50 and 80 euros per module. Of course, you have to add taxes to that, so that's quite a low price, I would say. Now, it's quite easy in Europe to produce your own solar energy, but it depends on the regional legislation. So in Europe, the European legislation is quite clear. We can all produce our own PV solar power and we can connect it to the grid, but it depends on the member states if they allow or not. So for instance, Spain had a rigid regime that did not allow you to produce your own solar energy, and even when you would live off-grid, you would have to pay a solar tax on your self-produced energy. This has been stopped right now, so that's good. The thing that is trending right now is, of course, also, do you want to produce your solar and then use everything and sell back to the grid, or if you're off-grid or even on-grid, store it in a what we call a solar battery, a lithium or lead acid battery. This is a small setup with lead acid. If you imagine a big lithium setup here, this system would provide enough electricity for the whole day, and you produce more during daytime and then store it for using at nighttime. Now, if you buy an electric car, for instance, which can store about 40 to 50 kilowatt hours of electricity, you can use your car as a mobile battery. With solar panels you can then fuel your car, you can store the energy in your car, drive with it, and you use it in the night time. And that's something we will see much more in the future. Okay, I have much more to tell, but given the fact that I got 25 to 30 minutes for this keynote speech, I like to give you some conclusions. So for domestic energy use, and then mainly in the northern colder hemisphere, we know that heating and cooling is very important, 2/3 of our domestic energy use. So the efficiency of the build of your house, so the insulation and the efficiency of this heating and cooling device is very important. And it's still, what I can see from practice, still lacking, and there's still a big room for improvement there. Many older homes are not insulated, and there's no trend to insulate them because of the high costs involved. So there's something that we must do. Then for energy labels for our home devices, it's a good idea, but when an A-label device is still not very efficient, you can ask yourself, okay, is this a good label? Or maybe we don't understand it so well. My second conclusion is therefore also we have to educate people on their home energy use, because if they know how much they use and what the costs are, then it's more easy for people to save on home energy use. Now, the trends in home electricity production, like solar energy, and in some places also small-scale wind, the cost reduction that we have seen now shows us that all over Europe, especially in the countries with high electricity prices, for instance Portugal, but also Sweden and UK, solar energy is much cheaper per kilowatt hour than the price of electricity from the grid. So home produced electricity has become more competitive. And I think with the trend of electric cars and the decreasing price of lithium batteries, that we will see a rise in home storage systems and even autarkic off-grid homes in the future. I thank you all for your attention, and I hope I can in some way via email or messaging I can answer your questions or remarks on my keynote speech. Thank you.